Now we're going to take a look at how the concentration versus time curve can be changed for the same reaction under different conditions. The ways that we can change it: we can change the concentration of a reactant, we can change a temperature, we can change the moles of a limiting reactant. These two will affect the rate of the reaction. This one will affect the extent of the reaction or where the endpoint is. It's important here that we're talking about the moles of the limiting reactant because we will have more or less product. The other two don't affect how much product we get, they just affect how quickly we get it. So if we take a look at this graph, if I do something that speeds up the rate, for example, increasing the temperature, increasing concentration, adding a catalyst, etc., then what I'm going to find is I'm going to get to the same endpoint. I'm just going to reach that more quickly. So the rate will be faster and it'll level off sooner. Let me draw that again a little more neatly and go on like that. Conversely, if I do something that decreases the rate, I will get to the same endpoint, but it will take longer to get there. It's a bit exaggerated and not a great shape, but you get the idea. If I make one of the other changes, which is changing the moles of the limiting reactant, I may get more or less product. So let's say I'm going to draw this one in green. I'm going to have more moles of reactant, so the reaction is going to go to a greater extent. Perhaps something like that. If I had fewer moles, it would do something like that. The reaction would happen to a lesser extent. So when I change the moles with more or less product, I'm going to have an increase in the change in Y or a decrease in the overall change of Y.